For most of human history, we believed our solar system was all there was. One star, 8 planets, a single way for worlds to exist. Well, that idea is gone. Today, we know the universe is filled with exoplanets, planets orbiting other stars, and many of them are unlike anything we ever imagined. These are strange new worlds. At first, exoplanets seemed familiar. Rocky planets, small planets, worlds not too different from Earth or Mars. Take the L98-59 system. Several planets orbit close to a small red star, some similar in size to Earth. Or GJ 357, another nearby system where rocky worlds circle their sun at distances that feel almost comfortable. Then there's TOI 700, a quiet red dwarf star hosting planets that sit within what we call the habitable zone, the region where liquid water could exist. For a moment, it felt like Earth might not be so special after all. And then there is Proxima Centauri b, the closest known exoplanet to Earth, orbiting the star nearest to our Sun, just over 4 light-years away. Proxima b is roughly Earth-sized and lies within its star's habitable zone, where liquid water could exist. But this world comes with a catch. Its star is a red dwarf, prone to powerful flares that may strip atmospheres and bombard the planet with radiation. Proxima b may be locked in a tight orbit, with one side facing eternal daylight and the other endless night. It is close, it is familiar in size, and yet it may be as hostile as it is tempting. And there is Gliese 12, a nearby red dwarf system just over 40 light-years away, hosting multiple small planets. One of them, Gliese 12b, is especially intriguing. It's similar in size to Earth and orbits close enough to its star that temperatures could allow liquid water, depending on its atmosphere. Unlike many red dwarfs, Gliese 12 is relatively quiet. Fewer violent flares, less stellar chaos. That makes this system one of the most promising places to study, where the small, rocky planets around red stars can remain stable and potentially habitable. Close, small, calm, and still very much unknown. But as we looked closer, the universe had other plans. Some exoplanets are labeled Earth-like, but that label can be misleading. K218b is one of the most famous examples. It's larger than Earth, a so-called super-Earth, with signs of water vapor in its atmosphere. But its gravity, pressure, and chemistry may be nothing like home. Kepler 186f orbits in the habitable zone of its star and is close to Earth's size. Yet it receives different light, has unknown oceans, and may be locked with one side permanently facing its sun. HD 21749c and Pi Mensae c remind us of an uncomfortable truth. Being in the right place doesn't guarantee being the right world. Earth-like does not mean Earth. And then things get extreme. Some exoplanets don't just orbit their stars, they are being torn apart by them. HD 189733b is a gas giant blasted by stellar radiation so intense that its atmosphere is literally evaporating into space. Winds scream across the planet at thousands of kilometers per hour, carrying glass-like particles through the sky. Kelt 9b pushes this even further. It is the hottest planet ever discovered, hotter than some stars. At these temperatures, molecules are ripped apart. Metals exist as vapor, This is not a planet you could stand on. It's a world in constant destruction. WASP-33b takes this to another level. This planet orbits so close to its star that its atmosphere is layered by extreme physics. As we move inward, temperatures rise rapidly. The upper atmosphere absorbs intense ultraviolet radiation. Below that, heat builds, molecules break apart, the planet glows from within, a world where chemistry, structure, and even gravity are being reshaped by heat. WASP-19 orbits so close to its sun that a year lasts less than a single Earth day. Its atmosphere is blasted by heat and stellar winds, creating chemistry unlike anything in our solar system. These are truly alien skies. Then there are smaller, harsher worlds. Planets like Pi Mensae C, HD 21749b, and LHS 3844b show what happens when rocky worlds lose their protection. LHS 3844b has almost no atmosphere at all. One side scorched under constant daylight, the other frozen in endless night. A planet split between fire and darkness. Our solar system now feels simple, because elsewhere, entire systems break the rules. TRAPPIST packs 7 Earth-sized planets into a space smaller than Mercury's orbit. Their skies would be filled with neighboring worlds hanging impossibly close. TOI 1338b doesn't orbit one star, it orbits 2. A circumbinary planet, moving through a sky with twin suns, rising and setting in unpredictable patterns. Kepler-69 and TOI 700 show us that planetary systems come in endless variations, layouts our textbooks never predicted. There is no standard design for a solar system. Not all planets even remain bound to their stars. Some are torn free and wander the galaxy alone. These are rogue exoplanets, free-floating worlds drifting through interstellar space, moving without a sun. Their skies never see daylight. Astronomers believe there may be billions of these lonely planets in the Milky Way, hidden between the stars. And then there are the worlds that barely make sense at all. Fomalhaut b is sometimes called a zombie planet. It may be the aftermath of a massive collision, a ghostly object surrounded by debris, reflecting light where no planet should survive. Some planets are unstable. Some are temporary. Some may not last long at all. The strangest part of all, we almost never see these planets directly. We find them by shadows, by subtle wobbles in starlight, by heat where nothing visible exists. Exoplanets reveal themselves not by what they show, but by what they disturb. Once, we believed Earth was the template. Now we know it's just one example. The universe is filled with strange new worlds, some familiar, some extreme, and some so alien they challenge the very idea of what a planet is. And we've only just begun to look. Thanks for watching and supporting the channel. Which exoplanet fascinates you most? Let me know in the comments below.